Today we're going to be looking at Unit 5, Similar Triangles, AA Similarity. So AA stands for angle, angle. So in similar triangles, all of the corresponding angles are congruent or equal to each other, and all of the corresponding sides are proportional. However, you don't need to show that all of them meet this criteria to show that the two triangles are similar. Angle-angle similarity is one of these shortcuts. So let's take a look at the first example. So we're going to use angle-angle similarity postulate. So the postulate says if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So let's take a look at this first example. So we want to show that two of the angles are congruent. By showing that, we can show that the triangles are similar. So if I look at it right off the bat, I have the first triangle is triangle LJK. The second triangle is triangle LPQ. Well, I notice that both of them share the same angle of L. So we have that angle L is congruent to angle L. And for the reason, we'll get a little fancy here. This is the reflexive property. One angle down, one more angle to go. So now let's take a look at another one. Well, we notice that these two are both parallel to each other. So since these two are parallel to each other, that means this angle and this angle are known as corresponding angles. And from what we know before, when we have corresponding angles, they have the same measure. There's two parallel lines cut by a transversal. Will be the transversal. Corresponding angles are equal to each other. So angle LPQ is congruent to angle LJK. And the reason for this is corresponding angles. So we've shown that two of the angles are congruent. So since we've shown that two of the angles are congruent, thus, by angle-angle similarity, or AA similarity, triangle KLJ is similar to triangle QLP. So these two triangles are similar to each other through the AA similarity postulate. Let's take a look at example 2. So example 2's got a lot that's going for it. So we're going to have a little bit of background for it, and then we're going to get into solving it. So when we look at this, there's a lot of information that we're told. The first thing is that the ball should bounce 25 feet from the wall. We're also told that it's going to bounce 11 feet to Tay. Tay will hit the ball when it bounces to a height of 42 inches, which is 3.5 feet. We need to find the point where this ball bounces. So when it bounces into the wall, we need to find that point. Since the wall and Tay form a 90-degree angle, we have AA similarity here. So let's start off with our sketch of what we have. So here is the wall. This is what we don't know. So this is going to be X feet. We know that it bounces 25 feet away. So this is going to be 25 feet. Here's our first right angle. Then it has to bounce 11 feet. So this is 11 feet. And then this is 3.5 or 42 inches. This is also 90 degrees. So this angle and this angle are the same, so that's one of them. This angle and this angle are also the same. So because of that, we can solve this out. So we're going to do 11 feet over its corresponding spot is 25 feet equals, now we're going to get into our unknowns. So this one is 3.5 feet over the wall, which we don't know is x feet. So we want to solve this. So the way we're going to solve this is we're going to cross multiply it. So this is going to multiply this, and then this is going to multiply this. So we get 11 times x, that's 11x. And we're going to multiply 25 times 3.5, that gives you 87.5. Divide both sides by 11. I get x equals 7.95 feet. So that means when the ball hits the wall, it's going to hit up on the wall at 7.95 feet. So we have the postulate at the beginning to help us identify. And then we're going to set up the triangles. And from the triangles, we're going to use our proportions, and we're going to use cross multiplication to solve it out.